Hi, this is part two of the the chapter two lectures on chemistry. Um, so we were talking about the octet rule, and you can see here what the definition is. The octet rule is a rule for all elements, and it states that except for the innermost electron shell, because the innermost shell only holds 2 electrons, we say that it is filled when it has 2 electrons. Atoms are more stable when they have 8 electrons in their valence shell, and their valence shell is the outermost electron shell. So I'm going to give you a few examples because I've looked through the slides and they really don't give you any examples in the slides. So I'm looking at a periodic table right now in front of me. You don't have to see it, but I'm just going to randomly pick. Okay, so calcium. I'm just going to use calcium for an example. Calcium has an atomic number of 20 and it has a mass number of 40. It's got an atomic mass of 40 point, I can't even read it, it's too small, I'm sorry, but it's a decimal. But anyway, it rounds to 40. So what that means, just for a review, is that calcium has 20 protons, because 20 tells us the number of protons. The atomic number tells us the number of protons. It has 20 protons. It has 20 electrons because the protons and electrons must balance. They must be equal. And then when you subtract 40, take away 20, it also has 20 neutrons. Although remember that the neutrons don't always have to equal the number of protons and electrons. But right now we're just concerned with electrons. So I'm going to draw a little model of calcium. All right, here's calcium. That's the nucleus, but we're just concerned with electrons. So this is just the nucleus, and then I'm going to draw the first energy level. This would be called the 1N, or the first energy level. Now, how many electrons will fill that energy level? Well, if you look up above, the octet rule says the innermost shell holds 2 electrons. So I'm going to put those 2 electrons here and here just to represent them. And then I'm going to draw the second energy level, which is 2N. And the second energy level and all the rest of the energy levels are filled with 8 electrons. So I'm going to put 8. In the second energy level. And then, I don't have a lot of space, but I'll do the best I can, the third energy level. So right now we have put 10 electrons in energy levels around the calcium nucleus. But we have 10 more to go. So the third energy level is filled again with 8. 1, 2, 3, 4, 5, 6, 7, 8. And that makes a total of 18. So we actually have to make a fourth energy level. There we go. And put how many electrons in the fourth energy level. If we have 18 already and we need 2 more to make it to 20, then we're going to put 2 electrons in the fourth energy level. So what that means is calcium in its atomic form, when it's just a neutral atom, is unstable. It's only going to be stable when its valence shell, its outer energy level, is filled with 8 electrons. Now, in calcium's example, okay, so what are the ways that you could fill the valence shell? You could fill the fourth energy level by adding 6 electrons. However, the easiest thing to do would be to take away these 2, lose these 2 electrons, because 2 is easier than 6. So taking away those 2 means that the valence shell is now the third energy level and it is already filled. So when calcium, here's how you would word it. When calcium loses 2 electrons, it becomes stable. It becomes chemically stable, okay, because of the octet rule. I'm going to do one more for you. I know this has taken a little bit of extra time, but erase all ink off Okay, that looks a whole lot better. Now, I'm going to try another one. Let's do, okay, so chlorine. Chlorine has an atomic number of 17. And I'm only going to write, that's the only number that matters for us right now. So when I do, this is going to represent the nucleus of the chlorine atom. This is the first energy level, the second, and the third. In the first energy level, we have 2 electrons. In the second, we have 8. That makes 10. So the third energy level will need 7. So what would need to happen to satisfy the octet rule? The valence shell is this one right here, the third energy level, and it would be stable if it gained 1 electron. And that's what needs to happen. When chlorine actually gains an extra electron, it becomes stable because its third energy level now has 8 electrons in it. Okay, now as far as electron orbitals, so it's a little bit difficult to explain, but what you're seeing are regions of space, okay? So if you think of the energy levels, you can think of the energy levels like the layers of an onion, okay? You have the core of the onion, and then you have layer after layer after layer. So the energy levels are just areas that are close to the nucleus and then further and further away as you go higher up in energy levels. But in the energy levels, within the energy levels, there are orbitals. Now, the definition of an orbital is the area where an electron is most likely to be found. So, this is very small, but this is the 2NP subshell is how it's worded. What that means is it's the second energy level. Everything in yellow represents the second energy level. What's in red represents the second energy level as well, but it's a different shape. So in the first energy level, you have what's in blue. So the first energy level would be all this in here. It would be this right here. All right. So the first energy level, you would call that the 1NS. I'm pretty sure with how they're doing the terminology that I'm seeing. I'm not a chemistry instructor, but I'm pretty sure that's what you would call it, the 1NS subshell, because the s orbitals are round. They're spherical shaped. And it doesn't mean the electrons are moving in a round pattern or a spherical pattern. The electrons move randomly, but it's telling you that if this is the nucleus of the atom, all right, this is the area around the nucleus where you're likely to find the first 2 electrons. Within that first energy level, they're more likely to be found within this spherical area around the nucleus than anywhere else. Now, in the second energy level, you have a 2NS, which is right here, subshell, and that is the same shape as the 1NS. It is a spherical shape. So the next 2 electrons are found in the 2NS subshell. So those 2 electrons are more likely to be found in this area than anywhere else. All right. And then you see these dumbbell shapes. They're already drawn for you. So each one of these is a p orbital. Each dumbbell shape is a p orbital. That's the 2NP subshell. And it's on the y-axis. There's one on the y-axis, the x, and the z-axis. But the 2NP subshell, the p subshells mean they're dumbbell shaped. That means that the 2 electrons in this subshell, because there'd be 2 in this one, 2 in this one, and 2 in this one. So you've got 2 in the 2s orbital, and then 2 in each of the p orbitals. That comes out to be 8 for the second energy level. In chemistry, you go a lot further with this. But for this class, I just want you to understand that orbitals are just regions where the electrons are likely to be found. Every pair of electrons has an orbital that it's most likely to be found in. So 2 electrons would be more likely to be found here than anywhere else around the nucleus of the atom. That's what that means. That's the p orbital in the second energy level. So every individual orbital holds 2 electrons, and the first energy level only has 1 subshell, 1 orbital, and it holds 2 electrons. The second energy level actually has a total of 4. The S subshell, the one that's red and spherical, and then the other 3 are the p orbitals. And each one of those orbitals holds 2 electrons. So 2 times 4 is 8. That's where the 8 electrons go in the second energy level. All right, the contrasting orbitals with the Bohr model. While the concepts of electron shells and orbitals are closely related, orbitals provide a more accurate depiction of the electron configuration of an atom. Because when you use the Bohr model, which is what I was drawing before on this page, that's called a Bohr model. When you just draw the energy levels as circles and you don't draw them as shapes. So it is more accurate to use the orbitals as pictures, but they're very difficult. It's very difficult to draw that and to even understand it. But the orbital model is more specific in where each electron is located. Okay, so we're going to move on to chemical bonds. That topic is really difficult even in chemistry class, what I talked about previously, the orbitals and all that. But I did my best. I hope it helped you a little bit. Please email me if you're still confused and you have questions. Okay, so it says, since not all elements have enough electrons to fill their outermost shells, like I gave you the example of calcium. Calcium only had 2 in its outermost shell, and chlorine only had 7. Atoms will form chemical bonds in order to satisfy the octet rule, in order to become chemically stable. So that's the reason for chemical bonds, is chemical bonds are formed as a direct result of the valence shell electrons. The outer energy level electrons are what determine which chemicals react with which chemicals. That's a real important thing to remember, okay? And it says that atoms form chemical bonds and therefore with other atoms, and therefore they obtain the electrons they need to attain a stable electron configuration and satisfy the octet rule. When 2 or more atoms chemically bond with each other, the result is a molecule. Molecules are 2 or more atoms chemically bonded together. And we're going to talk about some different ways that atoms can form chemical bonds. So we need to start with understanding ions. Okay, so some atoms are more stable when they gain or lose an electron, or 2 or maybe 3 electrons, when they gain or lose electrons. So if an atom loses electrons, then it's called a cation, because it has a positive charge, because it ends up losing negative charges, and there will be more protons or more positive charges left over. So cations mean that they have lost electrons, and anions mean that they have gained electrons. So a cation that I just showed you was calcium. When calcium forms an ion, it loses 2 electrons and takes on a +2 charge. When chlorine gains an electron, it gains a negative charge, so it takes on a -1 charge. You just can write it as just a minus. So this is an example. The chloride ion is an example of an anion, and the calcium ion is an example of a cation. Sodium is another example. Sodium needs to lose 1 electron because it has 1 electron in its outer energy level. So it's easier for it to lose that electron than to gain 7. So sodium loses 1 electron and becomes positively charged.